With exoplanet ROS 128b in the news, we pay a visit to the star that sustains this potentially habitable exoplanet. The red dwarf, ROS 128, hosts the temperate, Earth-sized planet ROS 128b. The star is about 20% of the Sun's diameter and 17% as massive. Sloan Digital Sky Survey. No matter where you look, the fecundity of the universe is manifest. Consider exoplanets. Since the first was discovered in 1992, astronomers have been piling them on like mashed potatoes at Thanksgiving. Today we know of more than 3,700. Of those, 53 may be potentially habitable. The most recently discovered potentially life-friendly planet, and in some ways the most exciting, is ROS 128b, which circles the red dwarf star ROS 128 in the constellation Virgo. Located just 11 light-years away, it's the second closest Earth-sized planet within the habitable zone of its star. Astronomers estimate that temperatures on ROS 128b range from -76 degrees to 68 degrees Fahrenheit to 60 degrees to 20 degrees Celsius. You could argue that's even more temperate than the lit of Earth and likely warm enough for liquid water to pool on its surface. What's more, its star experiences far fewer massive flares compared to other red dwarfs, making conditions more hospitable to potential life. If you have a 4.5-inch or larger telescope, you can track down ROS 128 in Virgo in the morning sky. Place Beta Virginis in the field of a low-power IBIS and you're halfway there. Mars location is shown for November 21st. Solarium. While you and I aren't going to see ROS 128b anytime soon, we can have the pleasure of seeing its host sun, ROS 128. Currently visible in a dark sky before the start of dawn, this newsy red dwarf is just 1.1 degrees southwest of 3rd magnitude Beta Virginis. To find the dwarf and its mind-eye planet, center Beta in the field of view and use the AAVSO map to star hop right to it. Once Beta is in the field of view, use this chart from the American Association of Variable Star Observers to star hop to ROS 128, also known as the variable star Phi Virginis. Numbers are stellar magnitudes with the decimals omitted, so 107 10.7. North is up. AAVSO with annotations by the author. Eager to see it for myself, I got up the first clear morning after the news of the discovery broke last week. Oh gosh, how easy could it be? Pale red and magnitude 11.2, ROS 128 is bright enough to spot in telescopes as small as 4 inches 10 centimeters. Mingled in the star's light were photons from its closely orbiting and perhaps habitable planet, a satisfying thought. Some 80% of the Milky Way's stars are red dwarfs, yet not a single one is visible to the naked eye. Being something of an introvert, I cotton to these shy suns. The brightest black eye 8760 in microscopium shines at magnitude 6.7. Despite the retiring nature, they make for fertile exoplanet hunting grounds. A tiny dwarf feels a much stronger, and more easily measurable, tug by an orbiting planet compared to a bigger star like our Sun. This graph shows how the distances of several nearby stars change over a period from 20,000 years in the past to 80,000 years in the future. 0 is the current time distances are given in light years. ROS 128 is closing in, as is Alpha Centauri. Around the year 25,000 AD, the Alpha Centauri system will be just 3 light years from Earth. Francesco Assisi SA 3.0. If we're patient and smart enough not to destroy ourselves, we'll have an even better view of ROS 128 in due time. The star is moving towards us at 31 km SEC and will become our nearest stellar neighbor around 81,000 AD, when only 6.2 light-years will separate the two Earths. We celebrate Thanksgiving this week, a time to be grateful for all we have. As we reflect on the ups and downs that sustain our lives, feel free to take another helping at the table, including this stellar cranberry.